Guys, we're going to do an example in chapter 5 involving probability, but really involving distributions. I should point out at the beginning, there are quite a few videos that I made that explain this in some detail and hopefully explain it in a common sense, down to earth way. The example we're going to be doing, the student asked me to do chapter 5, number 9. Let's click on it. Because I can't write the formulas, I'm going to try to follow the books. Show me an example. So in this example, I guess we should write the question. We have a bunch of data. Again, we have x and p of x, or this book calls it f of x, which is how often this particular outcome of a somewhat random situation occurs. So zero demand happens 40% of the time. A demand of 1 unit is 30% of the time, etc. These have to add up to 100%, which they do. And we're looking for, in the first case, what's called the expected value, which is a measure of what you expect to happen. Another way of saying this is the average. So the answer got to be somewhere between 0 and 3, but it's going to be closer to 0 because 0 has 40% of the probability and 1 has 30%. So the number's got to be closer to these numbers than exactly in the middle. So to do this in Excel, let's open the Excel file. I'm going to erase the previous one, which I was working on in preparation for this discussion. And again, the formula, as we see in the help me solve it, looks complicated, but E of x means the expected value of random variable x, meaning something that's random, is you multiply each x by its probability, and then you add them all together. Okay, in this case, this doesn't go to an infinite number, there's just 4 of them. So let's call this column x times f of x. It's done in Excel by putting an equal sign, B2 asterisk C2. I don't know why they don't like that. Oh, it's A2 times B2, sorry. A2 times B2. And this comes out to 0. You pull it down to multiply the other 3. You add them together, equals sum of, pull them down here again, close it with the enter sign, and the answer is 1. So the E of x, E capital X equals 1. Okay. Let's see what the book says. E of x is equal to, this is, they tell you here, the same data. They tell you to multiply it, just like we did, and you multiply it, add it, and you end up with an answer of 1, like I just demonstrated. You could use something called the sum product. In other words, there's another, you don't have to do sum and then multiply it and then add it. You can do it in one shot. But in this case, it turns out to be better to do it this way, as you'll see in a second. Now, so the average is equal to 1, but we know the numbers go from 0 to 3, meaning on every time you roll the dice, so to speak, you're not going to get 1, you're going to get a 0 or a 1 or 2. So the next question is, how much variability? Because that's going to be crucial for a lot of our subsequent chapters, and I think you understand this in common sense terms, or check the video that I made. How much variability is there from 1? Well, 40% of the time you're going to get a 0, which means that deviates by 1. 10% of the time you're going to get a 3, which deviates by 2 from the middle value of 1. So the formula for that is the variance of x is equal to each x minus the average, which was 1, square it, because you want to get rid of the minus sign. So negative times, if it's negative, squaring it, and then you multiply it or weight it by how often that particular outcome happens, and you add them all together. So we can do this. Let's say what the book is telling us. This is the formula. We can do this ourselves. Continue, add them all together. And they came out to an answer of 1 again. Just a coincidence, they won't usually be the same number. So let's go back to our Excel file somewhere. Lost it. I don't know why. There it is. There it is. So now we're going to do a column X minus E of X. By the way, E of X is sometimes called mu. Not really, I'm using a U, but it's the Greek letter mu. Just to make it more confusing, is pronounced in Greek me, but it's the average, and that's the same as U. So let's put it down here. U, or mu, is equal to. So I'm going to put it down as each number, which was the X, that was A2, put an equal sign, of course. A2, parenthesis, minus the average. We could put down as 1, or if you want to put it down as the average itself, which was column C7. Let's put down 1. Let's not get fancy about it. And we want to square it. So you do the top of the 6 squared. And that should come out to, in this case, 0 squared. 0 minus 1 squared is minus 1. Minus times minus 1 is 1. And I forgot to multiply by the f of x. So let's do it. X minus mu squared. We can do it in 2 stages. This is going to be called, let's call it x minus mu squared. We can do that. That's what this is. Now let's multiply it by the f of x. So it's parenthesis x minus mu close parenthesis squared times the f of x, which again is simply the how often that number happens. So we can do equals E2 times the probability, which was found in column B, times B2. So 1 is weighted, and then if you pull this down, both of them down actually, you're going to get these numbers here. The book calls this a 4. You can't have a 4 here, so let's call it a 4. Now it's a number, and doesn't change anything because multiplying it by 0, etc. Oh, 0 probability, so it won't really make a difference. We could drag it down if you like. Just add 0, drag it down to the next column, next row, I should say. Okay, so then we want to add together all this. Remember the formula says add together these squares times the f of x. So we can put down v of x, that was called the variance of random variable x, is equal the sum of column f, which in this case is simply hold here, enter, and again we saw the same thing as the book's answer of 1. Finally, because these numbers were squared to get rid of the minus sign, but they artificially blew them up. They squared them. So the opposite of squaring is taking a square root. So there's something called the standard deviation of random variable x, similar to the standard deviation of a sample, but not exactly the same. And it's equal to the square root, which I'm not sure if there is a square root function. I guess there is, SQRT, of the previous one, which was column F8. F8. And of course, the square root of 1 is simply 1. So that's the same. So all 3 answers were the same. The average was 1, the variance was 1, the standard deviation was 1. But that's just coincidence. That's not going to happen too often. So get rid of this. Let's go back to our demonstration example. And we should be finding the same stuff. 1, the standard deviation is 1, etc. And that's it. I'm going back to the old example, but our answer was right. Final check. And going to be the square root of, if the answer is 1.25, the answer, I might as well do while we're at it already, is the square root of 1.25. 1.25 square rooted is 1.118. So 1.11, or really 1.12. 2, check, and we got it right. And we're done. I'm going to stop sharing, X out the meeting.